In this video, we will solve the problems from exercise 6.5. Question number 1. Find the parametric form of vector equation and Cartesian equations of a straight line passing through 5 to 8 and is perpendicular to the lines 1 and 2. So, let's see the methodology that we will follow here. This is just an overview for your understanding. So, what we're going to do is, we need to find first the parametric vector equation, and the second is the Cartesian equations of a line passing through this point. So, you have the line passing through the point 5 to 8, and this line is perpendicular to these two lines. Okay, so what is the equation of the parametric form of vector equation of a line passing through a point and parallel to another line is given by r is equal to a vector plus t b vector, where a vector is the position vector A, where the point A is on the line. So, here the point A will be 5, 2 and 8. So, vector A will be 5 I cap plus 2 j cap plus 8 k cap. Okay, that will be our A. So, then T is a variable. So, we are not going to find that. Now, vector B is parallel to this line. Now, this line is perpendicular to these two lines. Okay, so now we know that this vector here, which we can define as, let's say, B1 vector, and this as D1 vector. So, B1 vector is parallel to this line and D1 vector is parallel to this line. So, if you do a cross product of B1 vector into D1 vector, B1 vector cross product with D1 vector will be perpendicular to the two given lines. So, since this is perpendicular to these two lines, it is going to be parallel to our required line. So, vector B cross product with D, B1 D1 is parallel to this equation here. Therefore, you can substitute this equation of r is equal to, put the value of vector A here, plus T times, find the value of B1 vector cross product with D vector, then you will get the parametric form of the equation. This is 1. Then the second part of the equation is to find the Cartesian equations. Now, for the Cartesian equation, you know the form is x minus x1 by b1 is equal to y minus y1 by b2 is equal to z minus z1 by b3. Now, x1, y1 and z1 is a point. So, this point is going to be our 5 to 8. So, we will be able to substitute these points here. Then, our b1, b2, b3 are the coefficients of the vector which is parallel to this given equation, or the drs of the equation of the line. So, we know that b1 cross product with d1 is parallel to this given line. So, finding this and substituting those values here, you will be able to find this. This is a very simple problem. Let's actually solve it. So, comparing the given lines with r vector is equal to a vector plus t b vector, and our vector is equal to, or the line R is equal to C vector plus S D vector, we can define our vector A is equal to this, which is I cap plus j cap minus k cap, and vector B is equal to this, which is 2i cap minus 2j cap plus k cap. Similarly, a vector C will be equal to this here, which is 2i cap minus j cap minus 3k cap, and our vector D will be equal to this vector here. So that's equal to I cap plus 2j cap plus 2k cap. So we need to find B cross product with D, because that is the vector which is perpendicular to these two given lines. So this is given by the determinant of I cap, j cap, k cap, and our B1, B2, B3 will be 2, minus 2 and 1, and our D vector coefficients of I cap, j cap and k cap will be 1, 2 and 2. Further, if we solve this, I cap into minus 4 minus 2 plus j cap into 4 minus 1, this is a minus here, plus k cap into 4 plus 2, you get this as minus 6 I cap minus 3 j cap plus 6 k cap. So vector B cross product with D is perpendicular to both the given lines. Therefore, the required straight line which passes through the point 5, 2 and 8 is R vector is equal to 5 I cap plus 2 j cap plus 8 k cap plus t times our vector B cross D would be B vector cross product with D vector. So that is 5 I cap plus 2 j cap plus 8 k cap plus t times minus 6 I cap minus 3 j cap plus 6 k cap. So parametric form of the equation has been found. So next let's find the Cartesian equations. So for this we need to express it as x minus x1 by b1 is equal to y minus y1 by b2 is equal to z minus z1 by b3. So replacing the values of x1, y1 and z1, which is the line, or which is the point through which the line passes through, you get the numerators as x minus 5 and y minus 2 and z minus 8. Then it is parallel to the vector B cross product with D. So the denominators will be minus 6 equal to minus 3 here equal to, and this will be plus 6. We can further simplify this as x minus 5 divided by 2, that is equal to y minus 2 divided by 1 which is equal to z minus 8 divided by minus 2. It's just dividing each of them by 3, then you get this Cartesian form of the equation. Question number 2. Show that the lines r is equal to, given by this expression and this, are skew lines, and hence find the shortest distance between them. So what's the methodology that we would follow? To show that these two lines are skew lines, we have to prove that they are not coplanar and they do not intersect. So, which means the condition vector c minus a, or the scalar triple product of b vector comma d vector, is not equal to 0, then the lines are skew lines. So we need to first find this. Once we find it, then to find the shortest distance between the two lines is given by the formula delta is equal to vector c minus a dot product with vector b cross product with vector d magnitude divided by b cross product with the magnitude. So if we find the value of this, then we find the shortest distance between them. So now let's proceed to do the problem. Comparing the given lines with a vector plus tb vector and c vector plus sd vector, our vector a is equal to 6i cap plus j cap plus 2k cap, and our vector b is equal to I cap plus 2j cap minus 3k cap. Vector c is equal to 3i cap plus 2j cap minus 2k cap, and our vector d is equal to 2i cap plus 4j cap minus 5k cap. The vector c minus a can be defined from c vector minus a vector will be minus 3i cap plus j cap minus 4k cap. Next we need to prove, c vector minus a, the triple product, is not equal to 0. So for the lines to be skew lines, so let's find the scalar triple product minus a, b vector, d vector is given by the matrix minus 3, 1, minus 4, 1, 2, minus 3, and vector d is 2, 4, and minus 5. So if we solve this, minus 3 into minus 10 plus 12 minus 1 into here into minus 5 plus 6 minus 4 into 4 minus 4, that would be equal to minus 3 into plus 2 minus 6, and minus 1 into 1 is minus 1, and this will be 0, so that's equal to minus 7. and that's not equal to 0. Therefore, the given lines are skew lines. So that takes care of the first part of the question. Then we need to find the shortest distance between the two lines. So to find the shortest distance, we need to find vector B cross product with vector D, which is given by the determinant I cap, j cap, k cap, and the coefficients of I, j, k of vector B is 1, 2 and minus 3. 1, 2, minus 3, and vector D is 2, 4 and minus 5. 2, 4, minus 5. Solving this, we can get as 2 I cap minus j cap. So this is our B vector cross product with D. Then the shortest distance is given by is equal to C minus A vector dot product with B cross product with D, the magnitude divided by the magnitude of B cross product with D. So solving this further, we can find our C minus A is given by this. So substituting the values of these into here and doing the dot product with B cross D, you can say that it's minus 3 into 2, so which is mod of minus 6 and minus 1 divided by the magnitude of vector B cross D would be square root of 2 squared plus 1 squared, so that will be 5. So your answer is 7 over root 5 units. Question number 3. If the two lines given by these two expressions intersect at a point, find the value of m. So here we are not given the value of m. This is a very simple problem. So let's directly go into the solving of the problem. So let's equate the first Cartesian equation, which is x1, x minus 1 by 2 is equal to y plus 1 by 3, which is equal to z minus 1 by 4 is equal to s. Okay, so we can say here. Okay, similarly, we can define our so further we can, rearranging this, we can say x is equal to 2s plus 1 and our y is equal to 3s minus 1 and z is equal to 4s plus 1. So that is our point. Now similarly, we can rearrange the second line as x minus 3 by 1 is equal to y minus m by 2 is equal to z, so which is z minus 0 by 1 equals to t. So here our x will be equal to t plus 3 and y will be equal to 2t plus m and our z will be equal to t. The given two lines are intersecting lines. Okay, so let's equate the corresponding coordinates. Okay, the coordinates are xyz here and xyz here. So equating them, you get 2s plus 1 is equal to t plus 3, and 3s minus 1 is equal to 2t plus m, and 4s plus 1 is equal to t. If we define our first equation as 1, 2, and 3, then we can say from 1 and 3 we can derive by substituting the value of t to be equal to, here t will be equal to 2s minus 2. So 2s minus 2 is equal to 4s plus 1, which would be our 2s minus 4s is equal to 1 plus 2, which implies our s is equal to minus 3 by 2. Now, if we substitute this in the first equation, so substituting s is equal to minus 3 by 2 in equation 1, we get 2 times of minus 3 by 2 plus 1 is equal to t plus 3, which implies our t will be equal minus 5. Further, substituting our s is equal to minus 3 by 2 and t is equal to minus 5 in equation 2 here, we can derive 3 into minus 3 by 2 minus 1 is equal to 2 times of minus 5 plus m. If we simplify this, we can find our m is equal to 9 by 2, hence the result.
Thank you for watching Maths Tutorial Anand. Please like, and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.